So we're going to continue on with the 1.2. Now we're going to talk about describing distribution. So let's go and see. Remember we did the U.S. women's soccer one, and that's on again. The dot plot is reappears on page 35 at the top, right? If you look at it. Okay, first of all, now that we know we have a little bit of description, we can say that the shape is what? What does this look like? Is this symmetrical, skewed to the left, skewed to the right?
Skewed to the right.
Looks like it's skewed to the right, right? Looks like it's skewed to the right. Okay, what else can we say? What else pops out on that from that distribution?
There's a gap.
There's a gap. Okay, that's good. What else? What can you say about that 9 and 10 over there?
They're outliers.
They're outliers, okay? They look like they're outliers, right? We do not know, because my definition of outlier would be different than yours, could be different, right? So it would kind of make sense from a statistical standpoint that there would be some sort of agreed upon definition of an outlier, right? And yes, there is, and we will talk about that later, okay? But, so again, we do not know if those are actually outliers. So we would say what? They appear to be outliers, right? So there appear to be outliers, okay? So, in the end, when we are describing the distribution, there are 4 things we need to talk about. Okay, so, and the mnemonics that we use here is SOX. Okay, so whenever I ask a question or somebody asks me on the AP Stats test or AP on the question to describe a distribution, you need to write, if it's quantitative data, if it's quantitative data, you have to discuss these 4 things. Okay, so you have to talk about the shape. You have to talk about the outlier. Outliers, whether there appears to be any outliers or not. C is the center. Then S is the spread or the range, okay? All right? Or the variance, or whatever you want to call it. So it's the shape, outlier, center, and spread. So if I were to describe that dot plot on page 35, I would say the distribution is skewed to the right. There appears to be 2 outliers. The center appears to be between 2 and 3. And I'd also say that the spread is from 0 to 10. Okay, because I have data points that go from, well, not 0, actually we don't have a 0, right? So it would be, spread would be from 1 to 10. So I would have to specifically call these 4 things out and describe them, okay? So when you are asked, again, when you're asked to describe a distribution, this is what I'm looking for, okay? I'm not gonna go over the example, okay? So let's go to page 36. When you're comparing distributions, also it makes sense that you would compare, if you have 2 separate distributions and you're comparing them against each other, you would compare them against each other using these 4 things, okay? And that's an example, household size, UK versus South Africa, okay? So if you look at that, so on the top, there is a dot plot of the household sizes in South Africa, and on the bottom there is a household sizes in the UK, and it asks you to compare the 2. So when you compare the 2, you would compare the shape, outliers, center, and variables. So are there any outliers on the UK household size? Anybody?
No, not really.
Not really, right? What about the South Africa? Is there any outliers there?
The 26th one.
So yeah, so imagine living with 26 people in your household, okay? But anyway, yes, so that again, there appears to be an outlier there, right? So that's one of the things when you talk about the outliers, we would discuss it that way. When you talk about the shape, you would say, well, looks like the South Africa is going to be skewed to the right, whereas the UK is roughly, I would say roughly symmetrical. The center for the South Africa seems to be between, I would guess, like 5 to 6, whereas the center for the UK is definitely going to be 2 to 3, or actually more likely 3. Okay, and the variability for the South Africa goes from 3 to 26, whereas the UK goes from, looks like it's 2 to 6. Okay, all right. So that's basically how you would compare them, all right? All right, so moving on. Now we're gonna go to stem plots. So we're gonna go to stem plots. So you've done this before. Stem and leaf plots, right? Stem and leaf plots. Stem and leaf plots. Let's go to page 37. The bottom part, there's a green box there. Read the definition of a stem plot. Okay, underneath that, there was a stem plot of the data. So you have 71, 104, 76, 88, 87, and on and so on and so on and so forth. And then you would create the stem plot. So the 6, 7, 8, 9, 10, 11, all the way through 12 are the tens and the hundreds, right? So 6 dash or 6/8 would mean 68, right? And that is the key. And every stem plot, stem and leaf plot has to have a key. Without a key, I do not know what this stands for. As far as I know, this could be 6.8. It could be 6,800, right? I do not know unless you give me a key that says 6/8 actually stands for 68. So you have to have a key there in your stem plot, okay? So blah, 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 blah. Let's look at the example on page 38. It says wearing your helmets. No, that's not do. Well, is that it? No, okay, all right, yeah. So let's do the example. Let's get the example. Wearing your helmets. If you're wearing your helmets, if you look at the solution, I'm not going to go through the whole thing. If you look at the solution, it has a key and it has everything, okay? If I were to ask you how this data is distributed, can you tell me about this just using the stem plot? Anybody have any idea there? Is it skewed to the right, skewed to the left, or is it roughly symmetrical?
Would it be roughly symmetrical?
Why do you think it's roughly symmetrical? You're correct. Let me know how you
Because there's a lot of end numbers that are near 22 and 23, and that's kind of where like the height is. And so if you kind of like tilt it to the side almost, like you look at it sideways, it looks like a graph.
You take this data, right, that's on a stem and leaf plot, and you have some here, you have some here, you have a lot here, you have a lot. You're not actually going to draw a bar graph, but you have numbers in here, right? And then you would actually just kind of tilt this like this, and you can see how it is roughly symmetrical, right? So from a stem and leaf plot, yes, you can tell how the data is distributed. You can also tell the spread, right? Because the lowest number is what on that example? What's the lowest example? What's the lowest data point? Looks like it's 20.8, and the highest is 25.6. So you also have that data too, right? Can you find the median from a 7-leaf plot? Sure you can, right? Because they are in from lowest to smallest to largest. They're already in order. You would just go from each end and count one in, and you can find what the median is. Okay, all right. So there's actually a lot of data that you can get from a stem and leaf plot. Okay. If you go to page 39, on the bottom part of page 39, there is what is called a back-to-back stem plot. So here you have, what is it? Resting and after exercise. This is, I think, your heart rate. Your heart rate is measuring your heart rate there. So if it's measuring your heart rate, and you have on the left-hand side, you have the resting, and on the right-hand side, you have after exercise. Okay, so what can I tell from that back-to-back stem plot there? Allison? What can I tell? Why would I ever use a back-to-back stem plot?
Because then it's easier to compare the resting and after exercise.
Exactly. That's exactly why you would use a back-to-back stem leaf plot, because it's directly, you can make the comparison very easily, right? Okay, good work. All right, so let's go there. So that is why you would use a back-to-back stem and leaf plot. Okay, so now let's go flip the page, go to page 40. Page 40, now we're gonna talk about histograms. Let's talk about histograms. So on a histogram, let's go to page 40. On the bottom, there's a green box there that defines histogram. A histogram shows each interval of values as a bar. The heights of this bar shows the frequencies or relative frequencies of values in each interval. Okay, right, so let's jump right into the example. Let's go to page 42. Let's go to page 42, and there's an example there. It says how much tax. And so this is the sales tax rate, right? The sales tax rate for each state, okay? If you look at the sales tax, this is what it looks like, okay? And then they drew, so if you look in there, where's Oregon?
We don't have sales tax.
That's right. That's why we are not there, right? So there is no sales tax in Oregon, so there is no data point. Okay. All right. So look at it. If you look at it, then they drew. Okay. So if you look at the solution, okay, they drew first. They made a frequency table, and the frequency table is actually the one in the middle, right? If you look at there. From 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. Can you see how those intervals would directly relate to a stem and leaf plot? Right? If I drew a stem and leaf plot, that's so the stem and leaf plot is going to look like this, right? It's going to look like 1, 2, 3, 4, all the way to 9, 10. Right? This is what the stem and leaf plot is going to look like. And I'm going to have numbers here, and then I'm going to add these numbers together, and that's how many I have between 1 and 2. The ones that are here are going to be between 2 to 3, 3 to 4, 4 to 5, and so on and so forth. So, and the frequency is how many leaves are on this stem, right? So I have 1, 0, 0, 1, 6, 15, 11, 9, and 4, right? So now I can convert this into a histogram, and that is converted over on on the first graph. The first graph is the histogram, right? That's the actual histogram. Okay. On B, the B says, what percent of values in the distribution are less than 6%? So less than 6% is what? So you'd be the 1, 0, 0, 1, and 6. So there are 8 of them, right? 8 out of the 47. So 8 over 47. All right. Okay. Everybody understand where the 8 came from there? That's just directly read off of the frequency table, right? Because 1 to 2 is 1, 2 to 3 is 0, 3 to 4 is 0, and 4 to 5 is 1, and then 5 to 6 is 6. So 1, 0, 0, 1, 6 added together is 8. Okay? So that's how you do that. That's how you would do a histogram. And actually, if you go to page 43, your calculator, your handy dandy calculator, TI-84, has the ability to draw a histogram for you. Okay? So you can actually have it do that. I'm not going to go over this. You can just follow through. All right? And let's go to page 45. Go to page 45. It says using histograms wisely. So how not to screw up a histogram, right? Number 1, do not confuse histograms and bar graphs. Can anybody tell me what the difference between a histogram and a bar graph is? The main difference between a histogram and a bar graph is what?
There's no big space between the bars in a histogram. They're all kind of flowing together, while in a bar graph, they're separate, like
no, that's
by a lot.
what I'm looking for.
The kind of data that they show.
It is the kind of data, right? Because a histogram is quantitative data, whereas the bar graph was what? Categorical data, right? Categorical data, that is the biggest difference, okay? So if you look at it, yes, okay, so the bar graph has separate spaces between the bars, okay, whereas the histogram does not, but that does not necessarily mean that. But also, so a byproduct of that is what? If you look at a shape of a histogram, it gives you some sort of insight to the distribution itself, right? But if you look at the shape of the bar graph, it has no meaning whatsoever, because the way I set each category really is what determines what is lower, what is higher, or the shape or whatever, all that stuff, right? So the shape really doesn't have any meaning in a bar graph. Does that make sense? Okay. 2, use percents or proportion instead of counts on the vertical axis when comparing distributions with different numbers and observations, okay? In other words, you cannot compare a distribution, all right, if you have one of them has a population size of 1,000 and the other one has population size of 10, okay? If you want to compare those two distributions, you're going to have to use the relative frequency, not the frequency itself, right? Because the one that has 10, you're going to have numbers like 2, 5, 3, or something like that, whereas the other one that had 1,000 would have numbers like 500, 622, or something like that, right? So you'd have to compare the percents or the relative frequency, right? That's number 2. Flip the page, go to number 3. Number 3 says, just because a graph looks nice doesn't make it a meaningful display of data. Okay? So if you look at the graphs down there, they are pretty looking graphs, but the one on the left is the first name length, and the second one is, it's the same thing, the first name length. But what does that mean? Does anybody really care? Does it make any difference? It really doesn't, right? So you have to make sure that when you're displaying stuff, it actually has some sort of meaning. Okay? Any questions on what we talked about today? if there aren't any questions, I want you to go back to page, where are we at? Page 30. Let's go back to page 30. Page 30. The orange box, the learning targets. First learning targets for 1.2 was to make and interpret dot plots, stem plots, and histograms. Does everybody feel comfortable that they know how to do that? The next one is identify the shape of a distribution from a graph. Okay. So what is that asking for there? Eva, what are they asking for? What do they mean there?
You would say like roughly symmetrical, or it's skewed to one side.
Correct. So you're looking to answer that as it's either roughly symmetrical, skewed to the left, skewed to the right, unimodal, bimodal, that type of stuff, right? Okay, so the next one, describe the overall pattern. What's the mnemonics that we use there? Lauren?
Socks.
Socks. Socks. And the S in the socks stood for what? This one's shape.
Shape.
O was?
Outliers.
Outliers. C was?
Center.
Center. And then the spread, right?
Mm-hmm.
So this is what you would use to describe the distribution. Okay, and then the very last one says compare distributions of quantitative data using dot plots, stem plots, and histograms. And again, you would try to use these things here to make the comparison. Okay, so if there are no more questions,